Okay, so in this video I'm going to go over the 8384 quiz review. So the first thing is it says find the inverse of the following function. So what we're going to do is we're going to put y where that f of x is. Then we're going to swap the x and the y. So we're going to put an x where the y was and put a y where the x was. Now we're going to put it in exponential form. So we're going to take our base here, 5, and it's going to become our base. We're going to take what was on the other side of the equal sign. That's going to be our exponent. And then we're going to put this and put it on the other side of the equal sign. So now to simplify this, we're going to divide both sides by 6. So our answer is y is equal to 5 to the x power over 6. Right there. Again, I'm going to put y where the f of x was. I'm going to swap the x and y. Now this time I'm going to put it in log form. So again, remember base is base, so that's the base. So this is log base 3 of what was on the other side of the equal sign. And that's going to be equal to y plus 2. So now we're going to subtract 2 from both sides. So our answer is log base 3 of x minus 2 is equal to y, because obviously there's nothing left over there now but y. Going to keep in the same process that we've been doing. Y equals 2 to the x power minus 7. Swap the x and the y. Now we're going to add 7 to both sides. So we get x plus 7 equals 2 to the y power. Going to put this in log form. So our base is our base, so that 2 is going to be our base, log base 2. What was on the other side of the equal sign is what we're going to take the log base 2 of. So that's going to be x plus 7, and then that equals y. That one was pretty easy. Here's our next one. Again, going to do y equals 5 times the log base 3 of 3x plus 4 minus 2. Swap the x and y. Okay, so we're going to add 2 to both sides. So that's going to end up being x plus 2 equals 5 times the log base 3 of 3y plus 4. Hopefully you can see the inverse of this. So we're going to divide both sides by 5. So that's going to be x plus 2 over 5 is equal to now log base 3 of 3y plus 4. Okay, so now we're going to put it in exponential form. So there's our base 3. So we're going to take 3 to the x plus 2 over 5 power. And we're going to set that equal to our 3y plus 4. So we're going to subtract 4 from both sides. I'm going to move it over here, y'all. So we're going to have 3 to the x plus 2 divided by 5 minus 4. That's going to equal 3y. So at this point, we're going to divide both sides by 3. So our answer is 3 to the x plus 2 divided by 5 power minus 4 divided by 3. That's equal to y. Now, you could also make that multiply by 1/3, because dividing by 3 and multiplying by 1/3 are the same. All right, here we go again. Y equals the log base 4 of x. Swap the x and y. Take our base, it's our base. Our exponent's what's over there, and that's equal to y. Okay, again, y equals 8 to the x power. X equals 8 to the y power. Our base is our base, so it's log base 8 of what's over here, x, that equals y. So now we're going on to 7, where it says graph the function, state the domain and range, list the transformations, find any intercepts, zeros, intervals, increase and decrease, asymptote, and behavior. So our function is log of x plus 3 minus 4. Okay, so when we do this, we know that our asymptote is related to this value right here. So and that value also has to do with our domain. So our asymptote is going to be x is equal to -3, and the reason that is because remember, this is x minus h plus k, and if there's a positive number there, then that means there was a negative number. So minus a minus 3 is a positive 3. So, so let's go ahead and plot that point. This is where our asymptote is going to be, and you guys know I like to do this in dashed lines so you guys can see it because it's an imaginary line. So then our domain is going to be x is going to be greater than -3, okay? And then our range is all real numbers. Now when we talk about our transformations, obviously that -3, right, that would be here, means it's going to go left 3, and then this -4 means it's going to go down 4. Okay, so now to find our intercepts, now what we know right now is that that graph is going to come in from the bottom, and it's going to go through the graph or through the y-axis. So we're going to have both x and a y-intercept for this problem, okay? So let's go ahead and solve for that now. So to solve for, let's go ahead and solve for the x-intercept first. So we're going to put 0 for y. So that's going to be log of x plus 3 minus 4. So we're going to add 4 to both sides. So that's going to be 4 is equal to log of x plus 3. Remember that when there is no base, our base is 10. So I'm going to put 10 right here because now we're going to say 10 to the 4th is equal to x plus 3. So that's going to be 10,000 is equal to x plus 3. So we're going to subtract 3 from all that. So that's going to be 9,997 is equal to x. So that's going to be both one of my intercepts. So this is going to be the intercept 9997, 0, and it's going to be my 0. So x is equal to 9,997. That means it's intercepting way out here, y'all. Okay. And then now let's also find our y-intercept, okay? So our y-intercept, when we do that, look up here, this time we're going to put 0 right here to solve for our y-intercept. So to do that, we're going to say y is equal to log of 0 plus 3 minus 4. So this one we can just put in our calculator. So the log of basically 3 minus 4. Okay, go ahead and do that in your calculator. Log of 3 minus 4. And when you do that, you should have got y equals, I got -3.523. So what that means is that our other intercept is going to be 0, -3.523. And this point we can plot right here. So -3.5-ish, there, right there, okay? So then we could find a few more points, but at this point we know that this graph is going to go on forever and ever and ever, so we can look at it on Desmos if we want. So here's the graph in Desmos, and we could pick a point out here, let's say like at 10, which is out here, and see where it's at. So it's at -2.877, so basically a little bit less than -3. So that'll help us get a little more accurate graph. So I'm going to plot that point, -2 about like there, okay? So we know this graph is coming along here and going out and across over here, right? Whoops, not as straight as possible, but you guys get the drift, okay? So now when we look at this graph, is the graph increasing from left to right or decreasing? Yes, it's increasing. So this is going to be none. And everybody watch, okay? So when we're talking about our interval of increase, it's going to be from here all the way to here. Remember, this is infinity over here. So this is going to be what? -3 to infinity. So our interval of increase is going to be from -3 to infinity. Now when we talk about our end behaviors, as we're headed this way on our graph, where's the graph headed? Isn't it going up, y'all? So it's headed towards infinity. And then as we head to the left towards negative infinity over here, where's the graph headed? Towards negative infinity, okay? All right, last problem. So this one, same thing. So when we look at this one, our domain and range are Let's actually talk about our asymptote again. So we know because of this, our asymptote is going to be at 4, right? Hopefully you guys know that by now. Our asymptote is going to be x equal to 4. And when we're talking about our domain is going to be x is going to be greater than what? 4. Our range is going to be all real numbers. Now, the difference with this graph is, y'all see this right here? This negative out front? I don't know what's going on with my... Let me do it this way. Y'all see this negative right here? That means we're going to have a reflection over the x-axis, okay? So that's a reflection over the x-axis. Then we're going to have that 4, which is going to be right 4. And then we're going to have the 6, which is going to be up 6, okay? So this graph, again, let's look at it on Desmos pretty. So here's the graph of this one, and you notice that, again, we got an asymptote of 4 here, and then it's going out to the right. This one is falling from left to right, and again, that's because it's a reflection over the x-axis. So if we look at 10 over here, we're at 5.2. If we look at 10 right here, okay, it's about basically at 4, y'all. So again, when we look at this graph, it's coming in up here, and it's going out. Whoops, sorry. We're not going down that far, y'all. It's going to go out like right up there, okay? So the intercepts, we're going to have to find those, the zeros, okay? So it's not going to intercept the y-axis at all. Is this going to increase or decrease, y'all? This one has no increasing, and our decreasing, again, remember, it's going to be from here to here, right? So that's going to be what? From 4 to infinity. So 4 to infinity. Our end behavior as we go right on the graph, it's going towards negative infinity. And as we go left on the graph, it's going towards positive infinity. Now let's find our x-intercept and our 0. So to do that, we're going to put 0 here is equal to negative log of x minus 4 plus 6. So we're going to subtract the 6 from both sides. That's still equal to the negative log of x minus 4. So if this is negative out there, then that's like a negative 1 out here. So we're going to divide both sides by negative 1. That's going to make that 6 positive, right? That's going to be 6 equals log of x minus 4. Now, here's where you got to remember that we have a base of 10. So we're going to take 10 to the 6th and equal that to x minus 4. So that's going to be 10. That's 5. So I think that's going to be one more 0. 10 to the 6 right there. And then this is x minus 4. So this is going to be 1,000,004. Because that was a minus 4 is equal to x. So when we talk about our intercept, it's going to be a 1,000,004. Yes. That's way out there, y'all. Comma 0. And that's also going to be our 0. So x is going to be equal to 1,000,004. Okay?